this next section, we're going to start looking at probability problems that are going to be a little bit more complicated because they're going to involve the words or and inside the probability. So we're going to learn how to tackle those. So in this first example, it says a pair of dice is rolled and the sum is recorded. After conducting the experiment 50 times, the following results are obtained. Then from this table, we're going to be asked to find several probabilities. I want you to notice that the probabilities that we were going to be finding here are empirical probabilities. Now that's just going to be just a reminder of the vocab that we had learned previously. These are going to be empirical probabilities because they're going to be probabilities that we're going to be calculating as the result of experimental data. Alright, so the first thing we're going to find is we're going to compute the probability that we get an even sum. Now, we could add up all of these frequencies. Frequencies is just a count of how many times it occurred. We could add up all these frequencies here to get the total number of trials, but we were also told in the question prompt that the trial occurred 50 times. So we know that the denominator in this probability is going to be 50 because that's the number of trials. Now, the numerator is going to be how many times an even sum occurred. So an even sum, so we have the 2 that occurred once, the 4 that occurred 3 times, the sum of 6 occurred 10 times, the sum of 8 occurred 8 times, the sum of 10 occurred 4 times, and the sum of 12 occurred 2 times. So adding up all of the times that we got an even sum, so 1 plus 3 plus 10 plus 8 plus 4 plus 2, that'll give us a count of 28. So we had an even sum occurred 28 times out of the 50 trials, and then that probability then can be simplified to 14 over 25. Now let's take a look at the next one. Compute the probability of a prime sum. So a prime sum. So the prime sums that we could get here would be either 2 or 3 or 5 or 7 or 11. Alright, so those are the prime sums that are available. So let's go ahead and pull all of those guys out. So the 2, the 3, the 5, the 7, and the 11. Okay, so a 2 occurred once, 3 occurred 0 times, the sum of 5 occurred 4 times, the sum of 7 occurred 12 times, and the sum of 11 occurred 2 times. So out of 50 trials, how many prime sums did we get? So 1 plus 3 plus 10, oh sorry, those are the wrong ones. We want to do the 1 plus 0 plus 4 plus 12 plus 2, the prime sums. Adding those up, we get 19 out of 50, which then that fraction can't be simplified, and we'll just leave it like that. Alright, so this starting getting into the types of probabilities we're going to be looking at in this section. Compute the probability of an even sum or a prime sum. That means if we got an even sum, we want to count it, and if we have a prime sum, we want to count it. Now again, we only read 50 trials of the experiment, so that's still going to be the denominator. So to build my numerator, I want to count any sums, their frequencies, if they were either even or prime. So the way I've kind of marked this up here is if I have the red circle or the blue rectangle around it, I want to count those frequencies. So 1 plus 0 plus 3 plus 4 plus 10 plus 12 plus 8 plus 4 plus 2 plus 2. That would give me 46. Was the frequency of any sums that were either even or prime out of the 50 possible rolls. So then this could then be simplified to 23 out of 25. Both of those divisible by 2. Alright, so this is leading us to a formula for how do we compute probabilities using the word or. We want to show that the probability of even or a prime sum, we can compute that finding the probability of even plus the probability of prime minus the probability it's both even and prime. So the probability was even, and I'm going to use the unsimplified fractions just to kind of ease the computations here. Even sums, the probability occurred 28 out of 50. Right here we found the prime sum that occurred with probability 19 out of 50. Alright, so then we want to find the probability that the sum was both even and prime. Now, this word "and" right here means it has to satisfy both criteria. The sum has to be an even number, and the sum has to be a prime number. Okay, so it has to satisfy both of these criteria. So what sums were even and prime? Well, just this sum right here, right? This is the only sum that is both even. Okay, so the even sums, those are the ones that I had the red circles around. And it's prime, those are the ones that have the blue rectangles around. So the probability that the sum is both even and prime, that occurred one way out of the 50 trials. Okay, so we're going to subtract that probability. So if we go ahead and do that, so if we do 28 plus 19 minus 1, you would get 46 out of 50, which simplifies then to 23 out of 25, which is exactly what we found up here. Now what we're doing here is that the reason why we're subtracting this off is that if I find each one of these probabilities separately, I've double counted somebody, right? This 28 counted this frequency in here, and this 19 counted it again. So if you're going to use this formula, what this part right here does is it subtracts off the element that was counted twice. So that works in general. If you want to find the probability of A or B, that's going to be equal to the probability of just event A plus the probability of event B, so kind of looking at them separately, and then you would subtract off the probability of A and B. Okay, so this would be then any of the outcomes that satisfied both of the criteria, and you subtract this off at the end to eliminate double counting anybody. So then keep in mind when you're finding out this last guy, because of this word "and", you would count outcomes that are in both A and in B. Okay, so the key idea is that there are outcomes in both. For this word "or" that occurs right here, what you would do here is you're going to count anybody that's in A or in B. Now, if they happen to be in both, I guess that just means they're extra special, but you don't count them twice. So a separate way of doing this probability, finding the probability of even or prime, that's kind of what we did right here, right? We just made sure we just didn't double count anybody. So we just went through here, we identified anybody that satisfied being even or a prime, meaning if anybody had a red circle or a blue rectangle around it, we wanted to count that in this event. And then we just made sure and we counted all these frequencies up. Okay, so the key thing on either approach, whether or not you want to use this formula or if you just want to kind of run through and count, is you just have to make sure you don't double count anybody.